Okay, I'm back here, still learning how to do this, but I figure with such an important lesson here, I would record this one too so I don't forget anything, and it seems to be working out okay. So simplifying expressions is what we're going to talk about today. The two statements that we are focusing on, I can simplify expressions by combining like terms. So you want to remember that phrase, combine like terms. And then I can simplify expressions by using the distributive property. And the second one is trickier than it seems and really gives students trouble. So you're going to have to pay close attention as we go over that. All right, so yesterday you wrote this down, I believe, or in the prior lesson, and we focused it on number 2 and 3, and now we're focusing on number 1. Combine like terms on the same side of the equal sign. That means that we're going to need to do that step first sometimes before we actually solve, as you'll see in the next couple lessons what I'm talking about. All right, I will have you take a moment and you can jot these down because these are all the ones we're going to go over here in just a moment. So you can definitely give some space, 2 or 3 lines for each of these between them to jot down work and so forth on how to do these. Space them out real good, and then we're going to go to them. So I'm sure you can pause the video to do that. And so we're going to jump right into the first one. Yes, 1 plus 1. Can you believe I'm asking you what 1 plus 1 is? Now at this point, most people are going to say the wrong answer because it's fun to say wrong answers on stuff that's easy. So 1 plus 1 we do know to be 4. No, 2. Okay, all right, there we go. 2. We got it. Now, I did that for purpose because I want you to see this. All right, 1x plus 1x. Not any different now. Think of xylophones. I have one xylophone and I, for some reason, get another xylophone. Not sure why, but now I have 2 xylophones. So just as 1 plus 1 is 2, 1x plus 1x is 2x. Voila, beautiful. Answer. Wrong highlighting color, that's okay. All right. Let's move on here to something a little bit more involved. Now here we have 2y plus 7y minus 5y. And it's very important to notice the signs that are to the left, or even the lack of signs to these. For instance, in this particular case, we have a 2y, and that's considered to be positive again because there's nothing to the left. So I have positive 2y plus 7y minus 5y. And we could tell ourselves a little story. Let's see. Benny, we'll go with Benny. Benny had 2 yo-yos, and then on his birthday tomorrow, yes, Benny has a birthday tomorrow, he gets 7 yo-yos. And so he has, of course, 9 yo-yos, but he happens to not be real kind to him and breaks 5 yo-yos in the same day. He might have been throwing them instead of using the proper purpose. But in the end, though, so 2y plus 7y, 9y minus 5y, we end up with 4 yo-yos left. That's how many Benny has. Still a fun birthday with 4 yo-yos. All right, now you're laughing at my silly jokes. All right, let's move on. Okay, negative 10z plus 6z minus 12z. Very important then to pay attention to signs. We're basically going to just combine what we call the coefficients, the numbers before the variable. So I'm going to take negative 10 plus 6 minus 12. I don't know exact example where I'm going to end up with a negative here because I have more negatives than positives. So I don't know if we can have negative zebras or anything like that. But so negative 10 plus 6, like I said, we just combine those, minus 12 or plus negative 12, right? Either way, it's the same thing. If I chick boom, right? Then that's where I get the plus negative 12 from. But however you look at it, that's where I'm combining. So negative 10 plus 6 is negative 4 plus negative 12, negative 16. Of course, then I put the z back on. And that's simplified. It's as far as I can go with that. All right, let's move on to another one here. All right, this one here, we have 6a plus 2b plus 5a plus 3b. Get all sorts of weird answers for this one, all right? So let's have a little story here again, because we love story time. All right, this time we're going to have Jenny and Jane, all right? Jenny and Jane, they both come together. Jenny here, okay, there's Jenny, all right? Yeah, there's Jenny, okay. And matter of fact, then let's see. Oh, we can take, no, I can't take that. So there's Jenny, we need Jane here. Okay, well, Jenny and Jane, I'm not sure where Jane is. Jane, show up here. She can be blue. Okay, Jane's over here. All right, there she is. Okay, now they each have brought apples and bananas. Okay, Jenny here has 6 beautiful apples there. All right, and she also has 2 bananas. Right, wow, those are beautiful. Okay, and over here we have 5 apples that Jane has. Weird looking apple. Okay, so I'm not sure, I wouldn't eat that apple. But then banana, she also has 3 bananas. Okay, and so we want to combine like terms. We want to simplify. So we say, how much do they have together? Well, together, they're not going to have so many apple bananas. You cannot combine your apples with your bananas. You can only combine your apples and your apples. Oh, somebody pointed out that I made a mistake, didn't I? Hey, good, we can get rid of the ugly apple, right? Now I have 5 apples. So 6 apples plus 5 apples. Together, Jenny and Jane have 11 apples, right? So we can say they have, let's use a little text box here. Maybe? Nope, it disappeared. Okay, text box. Try this again. 11 apples and 5 bananas. And that's simplified. I can't go any further than that because, again, we can't have apple bananas. So that's simplified right there. All right, let's do a couple more here. I want to do something with the distributive property. You would remember distributive property from earlier this year. Whatever's on the outside gets multiplied by everything on the inside. Sometimes they call it the fun truck. And so everything on the outside gets delivered to everything on the inside. So you have, and that means multiply. So I have 5 times x and then 5 times 6. So I'm going to have 5x, and like I said, 5 times 6, that's going to equal the 30 here. That's simplified now. That's using the distributive property. All right, people forget to do that second step all the way through. Now that should be review. And what's not review, something like this. Let me draw a little box in so we walk through this. Something like this. Now what I'm going to do in this particular problem, I think this is our last one, is I'm going to distribute first. All right, 3. I don't want to draw a shape. See, I'm still learning about this. I do make mistakes, as I found out yesterday. 3 times x, right? And order of operations, say I times, not add, right? I don't add first, do I? I times first, because the parentheses exponents, multiplication, all right? And then division, then addition, subtraction. So I'm going to do that, distribute. And I have 3x minus 18. Let that sink in. Now combine like terms, kind of like apples and bananas. I have numbers here and then an x. The x is already by itself. There's nothing to combine with that, so that's left alone. But 10 and 18, 10, look at the positive 10. Remember to the left, that's positive 10. That's a positive sign. Minus 18, then, I end up combining it and getting, I rearranged it. See how I rearranged it? Forgot I did that. And so positive 10, take away 18, I get negative 8 plus 3x. Or I could also say what? Yeah, I hear you in this fictitious room that no one's in. 3x plus negative 8. Very good. That's what I can get then. And that would be the other way right. Oh, somebody's saying, well, couldn't I say minus 8? Sure, yeah, we could say 3x minus 8 would be another way to write that. Definitely. All right. So that's all the fun we have for now, and I think it's time for you to practice a few. This has been Learning with Mr. Neff. Signing off.